Alright class, this is day 2 for unit 3. First thing I want to say is that we changed this first problem, or I did. There used to be another piece here and here. Just cross those pieces out. If you have an x plus 3 and an x plus 2 on yours, just cross it out. This is the starting problem, okay? So let's talk about this starting problem. We have, again, I talked about yesterday, the domain, which can either be a vertical asymptote or a hole. A vertical asymptote is a line that the graph doesn't cross, and it comes from the factors that are left over in the denominator after you simplify, versus a hole, which is a break in the graph, and the x coordinate comes from the factor that was canceled out. Then, to get the y coordinate, you sub in the x coordinate that was canceled out into the simplified function. So let's start with that. And these are, I'll talk about horizontal asymptotes and range in a minute. So first off, here are the 5 things we need. We need vertical asymptote, hole, horizontal asymptote, domain, and range. You guys should know the domain already. How to do that. X cannot be, and we look at this function before we cancel, and the things that make the bottom 0 are an x equals 1 and an x equals 4. Okay? Now, we simplify it. And I'm going to simplify it up here, but then write it down there. So if I simplify this, I'm left with just a 1 on top and an x minus 4 on bottom. So I'm going to just write this down here as I'm working. We did this yesterday. Now, here's where the new things are. We have to identify what pieces we have left. Well, on the bottom, we have this piece, which means at x equals 4, because it doesn't exist, there's a vertical asymptote. And remember, a vertical line is the equation x equals. So I'm going to say x equals 4 is my vertical asymptote. And we're going to show that on the graph here. So at 4, there should be a spot where it's like a wall. The graph will not cross that line. Okay. Now the other thing we have is a hole, because something canceled out. What canceled out? It's the other piece of the domain. The x minus 1 cancels out, which means that the x coordinate of 1, there's a hole. To find that, you have to plug in 1 into this problem for x, the simplified version. If you plug it into the original, you're just going to get 0 over 0. So we get 1 negative 1/3. Okay? Which is about right there. Oh, and I should also put that coordinate here. So far, those are the 2 pieces I found. I found that there's a wall there because it's left over, it's a vertical asymptote, and a hole there, which is a break in the graph. You can also find the y-intercept if you wanted to make it easier. If you put 0 in for x, you get negative 1/4, which is a little bit closer to 0, so it's crossing there, it looks like. And what else do we need? Now we need to talk about this horizontal asymptote. So the horizontal asymptote is based on the degree of the numerator and the denominator. So how many x's on top versus bottom in terms of power. They're guidelines for the end behavior that we talked about in the last couple of units. They can be crossed in your graph itself. It's just when you're going off to the ends, it's what it's approaching. So here are the 3 rules. If the top has more than the denominator, so if you have something that looks like this is a higher power, there is no horizontal asymptote. Okay? If they're equal, then they kind of cancel, and you only look at the biggest ones, and you're left with the numbers in front. So this would be y equals, in this example, 1/2. And finally, if it's like 1 over any x or x power, as x gets really big, y goes to 0. So that one's always 0. So if we look at our example, you can look at either the unsimplified or the simplified. There's 1x on top, but if you multiply the bottom out, there's 2 of them. Or if you look here, there's none and then 1. So if it's greater on the bottom, it's automatically y equals 0. So I'm going to just write that the horizontal asymptote is y equals 0. And what that means is that at the ends of the graph, that's what the graph's approaching. Okay. Range. Range you do at the absolute end of everything. You look at your graph and see, does it cross the horizontal asymptote, and does it cross the y-coordinate of the hole someplace else? If it does, it's not part of the range restriction, and no, it is part of the range restriction. Because range is like the y values that can exist, such as the domain was the x values that can exist. And usually they come from the horizontal asymptote or this y-coordinate of the hole. So we have to look at the graph now. Let's look at the graph and graph this. Alright, so here's my graph. Here's my equation. I already typed it in. And then I'm going to zoom 6 just to make sure. Okay, so here's what's going on. You guys should clearly see the wall here at x equals 4. The graph doesn't cross it, instead it goes down forever, and then on the other side of the wall it is going up forever and comes back down. And then notice as you go all the way to the right, okay, the graph is approaching the line y equals 0, and as you go to the left you can't see it, but it's just getting closer and closer and closer to 0. So let me sketch that graph. So the graph is approaching 0, going to the left, and then we have it goes through the hole, but again, oh, and you didn't see the hole in there. Usually it's hard to see on the calculator itself, but you do need it for your graph. So there we go. So now we look at the range. Again, the range you look at, does the graph cross this horizontal asymptote? It doesn't look like it does, right? It just jumps from here to here. So that means that y cannot be 0 because the horizontal asymptote is y is 0. And then look at this hole coordinate. Is there any other spot on the graph, if you draw a horizontal line through there, where it'll hit the graph? No. There's no spot in this graph where the y will be negative 1/3 because there's a hole there. So we'd also say then that it's not negative 1/3. Okay. And we have completed the problem. Alright, so let's do a couple more. Next, we have this. This is a weird one, but that's why we're doing that next. We have to see what our domain restriction is first, because we can't, well, it is factored and simplified. So if you set this part equal to 0, you get x squared is equal to negative 3. And you guys should remember that if you square root this, you get an imaginary. And that means that that is not part of the domain restriction. So the domain here is all real numbers. And this is the symbol for all real numbers. This R. X is all real numbers. You could also write out all real numbers. That's fine. Because of that, remember we get vertical asymptotes and holes from the domain restriction. Well, we have no piece that's real left over, right? So there are none. And then for the hole, nothing canceled out. So there's no hole. Now for the horizontal asymptote, you look at the rules. The numerator is less than the denominator for degrees. It's x to the 0 and x squared. That's just like the problem we had before. So we'd say that y is equal to 0. So all I know about this graph is y equals 0. And if I put x equals 0 in, you get 5/3. So if that's 1, that's 2. It's going to hit here. That's all I know. So now we're going to graph it. So let's graph this. Okay, I paused it just so we don't have to spend so much time typing it in. Here it is. And then if you graph it, look at the graph. Sure enough, it went through 5/3, and it's just a little hill here, right? Okay. And notice how the horizontal asymptote, though, is approaching the y equals 0 again and not crossing it. So our graph looks something like this. Now, just to double check, the range is weird here because the range is where does the graph exist or where can it not exist? Well, in terms of like in the y's. So you would agree that we don't hit the y and we don't go below it. So I'm going to shade kind of just where the graph exists. The graph exists from here, so in this region here, all the way down to here. So we have to find out what that inequality is in the y, so how high or low it goes. Clearly it stops at 0. So now we have to find the max. I think we did already, but just in case, let's double check that the max is the y. Oops. that the max is the y-intercept. I don't know how I turned my calculator into giving me fractions on this thing, but somehow I did. And sure enough, the maximum is 5/3. Okay, so what that means is that this is 5/3 comma 0, or sorry, 0 comma 5/3. So where does the y exist? The range is all the y values such that y is greater than 0, because it doesn't touch 0, it goes off to 0, and less than or equal to 5/3. Again, we're just talking about how much vertically the graph goes, and it only goes in that region. Excuse me. So, and that's all that was required for that one. That one's pretty basic. Before we do anything, we have to factor this one. Hopefully you guys notice your difference of cubes. And that's the factored form. Now remember, if you do quadratic formula with this, you'll get imaginary answers. So that's not part of the domain restriction. So the only thing part of the domain restriction here is that x cannot equal positive 1. Right here, from that piece. This piece doesn't matter for that. It will matter if there was a hole, but there's no hole because nothing canceled out. Vertical asymptote is what was left uncanceled. It's the same thing as the domain, x equals 1. So I know that there is a vertical asymptote at 1. I'll put that in right now. Now we also have to find the horizontal asymptote. Notice how the highest degree is x cubed and x cubed. So the numerator equals the denominator here, which means that you look at the numbers in front. So 2x cubed over x cubed is just 2 over 1, which means that the y, or horizontal asymptote, is 2. Okay, so I'm going to put that in 1, 2, and I'm going to just kind of do that. Remember, you can cross that line in here, just not over there or there. If you put x as 0 in, you get 0. So the graph goes through here. And that's it. Let's graph this. I have my graph ready to go. Let's view what we have. So there's that line y equals 2. Okay? So it kind of does a little weird dip there, but that's okay. But it looks like it's going down forever. So we're going to say that the graph does something like this. It starts at 2, kind of dips through there, and then goes down. It doesn't really matter. And then does this. Okay? So, the range. It's just what can the graph not go through. And if you look, does the graph go through the horizontal asymptote, y equals 2? No, it never crosses it. But the graph exists everywhere else. So we'd say the y just cannot be 2. Since there's no hole, that doesn't matter. So that's it. And one more. Okay. This one's already factored for you, so this should be easier to help us out. Let's get our domain restrictions. You get x is equal to 1/2. X is equal to negative 2/3. And x equals negative 7. So let's put those in first. Okay. So that's all my domain restrictions. Next thing you do is cancel something out if they cancel. So here we go. So the simplified form is 2x plus 1 over 2x minus 1 and x plus 7. Okay, now because we canceled that out, that domain restriction, this is the one that was canceled out. That's our x coordinate of our hole. We have to find the y coordinate. And our domain, or I'm sorry, our vertical asymptotes are the things that are left over. X equals 1/2 and x equals negative 7. Okay, and then let's look at the horizontal asymptote. If you FOIL this out, you get a 2x squared on the bottom and an 2x on the top. Hopefully you guys see that the denominator is greater than the numerator. So if it's bigger on the bottom, that's the y equals 0 again. Okay. Now we have to find the hole. you have to plug negative 2/3 into what's remaining. So that would be this simplified form. So we have 2 times negative 2/3 plus 1 over 2 times negative 2/3 minus 1, and then negative 2/3 plus 7. If you type all that in Math Fracket, you get 3 over 133. Okay? So let's start plotting what we know. We know at negative 7 there's a vertical asymptote. 1, 2, 3, 4, 5, 6, 7. So there's our vertical asymptote. We know there's another vertical asymptote at 1/2, which is right about here. We know there's a hole at negative 2/3 comma 1/33 or whatever. Yeah, so it's very small. It's like right there. And we know if we put 0 in, you get 1 over negative 7. Yeah, so it crosses like right there. Okay. And then we have a horizontal asymptote here and here at y equals 0. All right, let's graph this. All right, I'm ready to go. So I'm going to hit the graph button. And sure enough, okay, here's where you have to be careful. We have our 2 walls here and here, but notice that the graph goes down and then it crosses the horizontal asymptote in the middle here. Again, that's allowed because we're talking only about the end behavior. So what this graph looks like is something like this. It looks like it starts off here, goes down forever, comes from the top here, kind of curls through this hole here and here, and goes down forever at the vertical asymptote, so it should probably actually be closer to that. And then comes back up here, and then approaches the horizontal asymptote. So, this is a case where this line here will get as low as this 1/33 or 3 1/33 again. So, this will cover up the hole, because this will go all the way almost to 0. And notice how this graph crosses at 0 here. So even though there's a horizontal asymptote at 0, the line goes through it, so it's not a range restriction. Neither is the hole, because down here, this will be, you'll get to this value over here. So this is those weird cases where the range is all real numbers, because of this middle piece kind of crossing, and then everything else. So. Alright, are all the pieces that you need to know. I know it's a lot, but you'll get good at this. So.